let's write some functions in code also. Let's start with a simple task. We just have a function which takes in something and returns something. And maybe before even having functions which return or take in something, we can just see what is a function. Function we can define using def, and then we have a function name. Let's say it's print hello. So this function doesn't have any parameters, and it actually doesn't return anything, or we don't specify that it returns something. By default, Python returns none in this case. And now we just print hi. Okay, hello, because the name of the function is print hello. It would be bad to print actually something else, like print bye. And now what I have done, I have written a function which has some content. And now if I want to use this function, I can just call it by name. So I can print hello several times, just write it up 3 times. Of course, I could also do something like that I print it manually 3 times. But let's say the functionality changes. So print hello was okay, but now client says that, okay, hello should start with a capital letter, for example. Now, if I have it in function, I can change it in one place, and every call out to this function already executes it in a new way. So there is 3 times I get hello with capital letter. If I add those prints separately, I just should replace it in 3 places. Currently the code is simple, it's everything in one file, but let's say the code is in hundreds of different files, then it's more inconvenient to find all the places where this function or this print is called out, and then to change those values here. Of course, you can use some find and replace functionality and so on, but it's still more inconvenient. Instead, I can call out this function. Now what happens is that instead of this call out, basically Python goes into this line, executes it, and then continues here. Now it's also the same call out. It goes into this function, executes it, and so on. So basically this is like reading a book, and at certain times you maybe have to see the references about some characters, for example. There are some I don't know, some names of the characters. Then you want to see who was that and what was his or her story and so on. So you go and see from the back of the book what was written about this character and so on. So basically, and after checking out, you continue your reading from where you left off. So basically it's the same. The Python sees that there is a function callout. It goes and executes the code and then returns, and the code execution continues from this part. Okay, this was the simple part. There is no input, there is no output for the function. Usually we do have some input, and usually we do have some output. And let's say we have a function add, which adds up to numbers, or add numbers, or whatever. There are different ways to call it, but let's keep it simple and write it as add. And let's say we have 2 numbers, a, and I specify the type hints also here. So the a should be integer and b should be integer, and it returns also integer. Of course, actually we could also use floats here, so I don't really only have to accept integers, but let's say it's a simplified version where we only have integer numbers. And now what we do, we return a plus b. So currently what we have a function which takes in two values, a and b, that's 7 and 9, and it outputs 1 number, so it should be 16. What happens here is maybe not important or not relevant, or we don't care about it. We do want to know that if I put in something, I get something out. Usually that's the case. I mean, there can be functions where there are more inputs. There can be functions where is one input and several outputs. There can be functions where are no inputs, but there's output. There is also a function where there is only input, no outputs, and there is function which has none or no inputs, no outputs. This is like the printer law. So basically, the functionality or how this function behaves doesn't depend anything. We cannot control the function behavior, which is usually not very good. Usually we still want to somehow control how the function works. So for that we have these input values. And usually we would like to get something out of the function, because otherwise what goes in stays there, so we cannot get anything out from that. So usually the normal way is that we have several inputs and maybe one to several outputs, and that's the idea of the function. So we can do some complex stuff here. We put something in, we get something out, and we don't actually care how it's done. I mean, of course, if we implement it, we care because we have to implement it. But otherwise, if it's done by someone else, we don't care. Basically, the print is a function. Print is a function where we can put something in. Actually, print doesn't return anything. It prints out, it does something, we can see the code. But if I would do something like that, let's print out, let's make it simpler. Result is print hello. Now I want to see what's the value of the result. So if I execute the code, I see that this print here is none. So the print actually doesn't return anything, or in Python everything in that case returns none. But there's nothing meaningful. I mean, this doesn't depend on the contents or the input of the function. So, and if I add this function add here, so basically this is a function which takes in two parameters or two values, and then we do something with those, some magic, and then we get something out. And now if I want to use this function, I can just call it by name. The idea actually is so that if I add this add function, it points somewhere into memory. So we have drawn some memory pictures before also. So basically the add function is here. So basically there is this definition, a plus b return, whatever, doesn't actually matter. So the definition of this function is in this memory slot, or actually it takes more than one slot. It's memory, yeah, it's portion of memory. And if I call out add, then it checks where this name points. So basically add is like a variable. It points to object, but currently the object is function. So it sees that add is a function. If I call it out, then it executes this function. If I would write, for example, print add, but without the parentheses, I will get a result which says that this is a function. So basically this is the function. It understands that function is here. If I want to execute the function, I have to add parentheses there. So add. What it does, it checks what is this, where do this name points. So this name points to this function, and now those are passed into this function and we get something out. So to actually execute the function, we have to add parentheses here, and here I can put 1 and 2, and now I get, instead of this function which was written here, I get the result which should be 3. Let's see, yes, it works. So this is the idea of the function. I can do something maybe complex, maybe not so complex, That doesn't have to be complex always, but I can put something, some functionality, and give a name to this functionality. Currently it's add. I mean, add is not so meaningful because adding two values is simple enough, but if I already have some more complex calculation, it's good to have a name for this calculation, and then it's easy to read this code. For example, if I want to calculate some concrete formula, then instead of using this formula inside the code, it's not easily understandable what's written in this code. For example, I want to calculate the area of a triangle. So if I write that the area is, and let's put calculation here, I can do that. I can do that so it's, okay, I have to have a and base and the height of the triangle, and then I can write this is a times h divided by 2. This works. I can execute it. I should get 150, yes. But it's not so easy to understand this code. I mean, of course, if I know the triangle area, it's okay. But even, I don't know, I mean, there are, of course, other ways where you can multiply two values and divide by 2. For example, in certain cases where it is not an area of a triangle. So instead, we usually have a function get triangle area h and return. Let's try to write this. Yes, of course I could add type hints here. Okay, this can be float. This can be float, and this returns float. We could have even a docstring. Calculate area of a triangle. Okay, this is like cool example. Of course, I should have two empty lines before and after the function definition. So, and now if I basically do the same thing, area is, but now I call out to get triangle area and h. And for the reader, it's so much more understandable that, okay, yeah, now I calculate triangle area. I even don't care actually how it's done, but I know that this is triangle area. If I do care about how it's done, then I can check it out if I want. But usually I just want to see what's done and why it's done. And in this case, it's very hard to understand. Okay, here I even actually print it out, but sometimes you just calculate it and do something else with the value. Then it becomes more complex to understand what's actually done and why and so on. But here it's stated that now I calculate the area of a triangle, and now I can use this information to kind of understand what is printed out. It's just not multiplication of two numbers and divided by 2, but it's actually triangle area. That's one way, one reason to use functions. Even the simpler ones, even the one-line functions are good in a sense that I can verbose or give more information about the code or some calculations. Let's see what happens with the name pointing to a function. Basically, as I mentioned, it's the same as variable pointing to a function or to a memory or value in the memory. So currently I have a function called add. Everything works. But now what happens is if I write that add is 10, now the name add points to this point of the memory, this slot in the memory where 10 is stored. So basically there is no reference to the function anymore. And now the problem is that if you do that, there's no error in Python. Python allows you to do that. In other languages, you would have a problem with that. And now if I want to print out add, I get an error. And the problem is that the add, error is here, the add is actually integer. So it says that I cannot call out integer. So basically it's just like a variable x. And now I try to do x7, whatever. So now the same happens here. Even though I add the function called add, the name add points to this function in the memory, but I overwrote it here. I assigned some value 10 to this variable. Now this name or this variable points to another slot in memory where a number is stored. So you have to be careful with your function or the function and also variable names. Usually the IDE also gives you pointers about that. For example, here PyCharm gives me a warning that this int object is not callable, although it actually doesn't give me a warning here. It could give me a warning already here because I'm overwriting a function. Yes, it does not. And what often can happen is that, for example, you want to calculate the sum of two numbers and you write sum is equal to, or we assign value to sum, which is 1 plus 2. Now what happens is that there is otherwise a built-in function sum, which calculates sum of a list. So it sums up every element in the list. Now I cannot use it because if I do, let's say that, I get an error because int is also not callable because the value inside sum is 3 and I cannot call out 3. Okay, I still get error from here. I comment it out. Now I should get actually the same error but in different line. So it's written also here, it's line 3 or 31. I can click here. I see that this is this line here. And the problem is that I have overwritten the name sum, which originally pointed to a function. Now sum points to 3. So you have to be careful which variables you use. I guess now it shows me that, yeah, this sum variable shadows built-in name sum. So it means shadow means that it's kind of like basically it means that you cannot use this sum function, at least not by this name. The function itself is still exists. You cannot kind of erase it from Python. There are ways to call it still out somehow, but currently not by this reference. There are also way that let's say there is sum which points to a memory where there is a function. I can have a function or name x which also points to this same place. So basically I can, let's say I delete those. Let's say I say that total is same as sum. Now what happens is that this total, this is total. Total points to the same place where the sum points. And now I can call out, let's print total of 1, 2, 3. So yeah, now the total is 6 here. It sums up all those elements inside the list. So you can do that so that two names point into the same place in memory. There are different cases where if you assign the same value into those two variables, they don't point into the exact same element or the same value. But yeah, in that case, when we have mutable objects here, then we can say that if I change or do something with this name, the same can be done or the same happens to this name. So basically it's if you have a if you're living in the corner, there are two streets, street A and street B. Let's say it's the first house for both. Those are roads. And you can say that your address is both A1 and B1, they both point to the same house. So if I do something with A1, for example, if I paint my roof to green, then B1's roof is also green because they point to the same place. And this actually doesn't apply for functions. I cannot change a function somehow during the code, but still it's good to know that in Python name points to value or name points to object. The names are usually variables. We tend to use them mainly as variables, but also functions or even the methods or the objects, they are names or actually where you store those are still variables. So the name points to a object. Currently the object here is function. The object can also be a value, and you can assign or you can get the value behind the name in your code using this name, for example, printing it out or executing this whatever is inside this name. So this is something which is often not you cannot do in other languages. You cannot use the same kind of names for variables and functions. Functions and variables have different namespace in certain languages, but in Python they all share the same namespace, meaning that the x can be function or it can be a variable. Of course, it cannot be both at the same time, so you have to pick which one the x currently is. But this can be confusing, and especially in cases where you use, for example, sum is very often used in certain cases where you want to sum up the elements in a list, then it's convenient or very often a variable called sum is used, not knowing that you currently kind of shadowed the built-in function sum. But the IDE should point it out, and maybe after watching this video you will not use sum variable, rather use total or something like that, sum of elements, or this is also acceptable.